The Western Philosophy, Will Durant. Chapter 2, the fourth section. The Organization of Science. Socrates says, Renan gave philosophy to mankind, and Aristotle gave it science. There was philosophy before Socrates, and the science before Aristotle, and since Socrates and since Aristotle, philosophy and science have made immense advances. But all has been built upon the foundation which they laid. Before Aristotle, science was in embryo. With him, it was born. Earlier civilizations than the Greek had made attempts at science, but so far as we can catch their thought through their still obscure cuneiform and hieroglyphic script, their science was indistinguishable from theology. That is to say, these pre-Hellenic peoples explained every obscure operation in nature by some supernatural agency. Everywhere there were gods. Apparently it was the Ionian Greeks who first dared to give natural explanations of cosmic complexities and mysterious events. They sought in physics the natural causes of particular incidents, and in philosophy a natural theory of the whole. Thales, 640 to 550 BC, the father of philosophy, was primarily an astronomer who astonished the natives of Miletus by informing them that the sun and stars, which they were wont to worship as gods, were merely balls of fire. His pupil Anaximander, 610 to 540 BC, the first Greek to make astronomical and geographical charts, believed that the universe had begun as an undifferentiated mass from which all things had arisen by the separation of opposites. That astronomic history periodically repeated itself in the evolution and dissolution of an infinite number of worlds. That Earth was at rest in space by a balance of internal impulsions, like Buridan's S. That all our planets had once been fluid, but had been evaporated by the sun. That life had first been formed in the sea, but had been driven upon the land by the subsidence of the water. That of these stranded animals, some had developed the capacity to breathe air, and had so become the progenitors of all later land life. That man could not from the beginning have been what he now was. For if man on his first appearance had been so helpless at birth, and had required so long an adolescence, as in these later days he could not possibly have survived. Anaximenes, another magician, 450 BC, described the primeval condition of things as a very rarefied mass, gradually condensing into wind, cloud, water, earth, and stone. The three forms of matter, gas, liquid, and solid were progressive stages of condensation. Heat and cold were merely rarefaction and condensation. Earthquakes were due to the solidification of an originally fluid earth. Life and soul were one, an animating and expansive force present in everything, everywhere. Anaxagoras, 500 to 528 BC, teacher of Pericles, seems to have given a correct explanation of solar and lunar eclipse. He discovered the processes of respiration in plants and fishes, and he explained man's intelligence by the power of manipulation that came when the four limbs were freed from the tasks of locomotion. Slowly in this man knowledge grew into science. Heraclitus, 530 to 470 BC, who left wealth and its cares to live a life of poverty and study in the shade of the temple porticos at Ephesus, turned science from astronomy to earlier concerns. All things forever flow and change, he said. Even in the stillest matter, there is unseen flux and movement. Cosmic history runs in repetitious cycles. Each beginning and ending in fire. Here is one source of the Stoic and Christian doctrine of last judgment and hell. Through strife, says Heraclitus, all things arise and pass away. War is the father and king of all. Some he has made gods, and some men, some slaves, and some free. Where there is no strife, there is decay. The mixture which is not shaken decomposes. In this flux of change and struggle and selection, only one thing is constant, and that is law. This order, the same for all things, no one of gods or men has made, but it always was, and is, and shall be. Empedocles, 430 45 BC in Sicily, developed to a further stage the idea of evolution. Organs arise not by design but by selection. Nature makes many trials and experiments with organisms, combining organs variously where the combination meets environmental needs. The organism survives and perpetuates its like. Where the combination fails, the organism is weeded out. As time goes on, organisms are more and more intricately and successfully adapted to their surroundings. Finally, in Lysippus, 445 BC, and Democritus 462 360 BC, mastered and pupil in Thracian Abdera, we get the last stage of pre-Aristotelian science, materialistic, deterministic atomism. Everything, said Lysippus, is driven by necessity. In reality, said Democritus, there are only atoms and the void. Perception is due to the expulsion of atoms from the object upon the sense organ. There is, or have been, or will be an infinite number of worlds. At every moment, planets are colliding and dying, and new worlds are rising out of chaos by the selective aggregation of atoms of similar size and shape. There is no design. The universe is a machine. This, in dizzy and superficial summary, is the story of Greek science before Aristotle. Its cruder items can be well forgiven when we consider the narrow circle of experimental and observational equipment within which these pioneers were compelled to work. The stagnation of Greek industry under the incubus of slavery prevented the full development of these magnificent beginnings, and the rapid complication of political life in Athens turned the sophists and the Socrates and Plato away from physical and biological research into the paths of ethical and political theory. It is one of the many glories of Aristotle that he was broad and brave enough to compass and combine these two lines of Greek thought, the physical and the moral. That going back beyond his teacher, he caught again the thread of scientific development in the pre-Socratic Greeks, carried on their work with more resolute detail and more varied observation, and brought together all the accumulated results in a magnificent body of organized science. Paragraph 2. Aristotle as a naturalist. If we begin here chronologically with his physics, we shall be disappointed, for we find that this treatise is really a metaphysics, an abstruse analysis of matter, motion, space, time, infinity, cause, and other such ultimate concepts. One of the more lively passages is an attack on Democritus' void. There can be no void or vacuum in nature, says Aristotle, for in a vacuum all bodies would fall with equal velocity, this being impossible. The supposed void turns out to have nothing in it. An instance at once of Aristotle's very occasional humor, his addiction to approved assumptions, and his tendency to disparage his predecessors in philosophy. It was the habit of our philosopher to preface his works with historical sketches of previous contributions to the subject in hand, and to add to every contribution an annihilating, refuting. Aristotle, after the Ottoman manner, says Bacon, thought he could not reign secure without putting all his brethren to death. But to this fratricidal mania we owe much of our knowledge of pre-Socratic thought. The system. He prefers to give that honor to the earth, but the little treatise on meteorology is full of brilliant observations, and even its speculations strike illuminating fire. This is a cyclic world, says our philosopher. The sun forever evaporates, the sea dries up rivers and springs, and transforms at last the boundless ocean into the barest rock, while conversely the unlifted moisture gathered into clouds falls and renews the rivers and the sea. Everywhere change goes on, imperceptibly but effectively. Egypt is the work of the Nile, the product of its deposits through 1,000 centuries. Here the sea encroaches upon the land, there the land reaches out timidly into the sea. New continents and new oceans rise. Old oceans and old continents disappear, and all the face of the world is changed and rechanged in a great systole and diastole of growth and dissolution. Sometimes these vast effects occur suddenly and destroy the logical and material basis of civilization and even of life. Great catastrophes have periodically denuded the earth and reduced man again to his first beginnings. Like Sisyphus, civilization has repeatedly neared its zenith only to fall back into barbarism and begin decouple its upward travel. Hence, the almost eternal recurrence in civilization after civilization of the same inventions and discoveries, the same dark ages of slow economic and cultural accumulation, the same rebirths of learning and science and art. No doubt some popular myths are vague traditions surviving from early cultures. So the story of man runs in a dreary circle because he is not yet master of the earth that holds him. The third paragraph. The foundation of biology. As Aristotle walked wandering through his great zoological garden, he became convinced that the infinite variety of life could be arranged in a continuous series in which each link would be almost indistinguishable from the next. In all respects, whether its structure or mode of life or reproduction and rearing or sensation and feeling, there are minute gradations and progressions from the lowest organism to the highest. At the bottom of the scale, we can scarcely divide the living from the dead. Nature makes so gradual a transition from the inanimate to the animate kingdom that the boundary lines which separate them are indistinct and doubtful, and perhaps a degree of life exists even in the inorganic. Again, many species cannot with certainty be called plants or animals, and as in these lower organisms, it is almost impossible at times to assign them to their proper genus and species. So similar are they. So in every order of life, the continuity of gradations and differences is as remarkable as the diversity of foundations and forms. But in the midst of this bewildering richness of structures, certain things stand out convincingly: that life has grown steadily in complexity and in power, that intelligence has progressed in correlation with complexity of structure and mobility of form, that there has been an increasing specialization of function and a continuous centralization of physiological control. Slowly life created for itself a nervous system and a brain, and mind moved resolutely on towards the mastery of its environment. The remarkable fact here is that with all these gradations and similarities leaping to Aristotle's eyes, he does not come to the theory of evolution. He rejects Empedocles' doctrine that all organs and organisms are a survival of the fittest, and Anagoras' idea that man became intelligent by using his hands for manipulation rather than for movement. Aristotle thinks, on the contrary, that man so used his hands because he had become intelligent. Indeed, Aristotle makes as many mistakes as possible for a man who is founding the science of biology. He thinks, for example, that the male element in reproduction merely stimulates and quickens. It does not occur to him what we now know from experiments in parthenogenesis, that the essential function of the sperm is not so much to fertilize the ovum as to provide the embryo with the heritable qualities of the male parent, and so permit the offspring to be a vigorous variant, a new admixture of two ancestral lines. As human dissection was not practiced in his time, he is particularly fertile in physiological errors. He knows nothing of muscles, not even of their existence. He does not distinguish arteries from veins. He thinks the brain is an organ for cooling the blood. He believes, forgivable, that man has more sutures in the skull than woman. He believes, less forgivably, that man has only 8 ribs on each side. He believes incredibly and unforgivably that woman has fewer teeth than man. Apparently, his relations with women were of the most amicable kind. Yet he makes a greater total advance in biology than any Greek before or after him. He perceives that birds and reptiles are near allied in structure, that the monkey is in form intermediate between quadrupeds and man, and once he boldly declares that man belongs in one group of animals with the viviparous quadrupeds, our mammals. He remarks that the soul in infancy is scarcely distinguishable from the soul of animals. He makes the illuminating observation that diet often determines the mode of life. For of beasts some are gregarious and others solitary. They live in a way which is best adapted to obtain the food of their choice. He anticipates von Baer's famous law that characters common to the genus, like eyes and ears, appear in the developing organism before characters peculiar to its species, like the formula of the teeth, or to each individual self, like the final color of the eyes. And he reaches out across 2,000 years to anticipate Spencer's generalization that individuation varies inversely as genesis, that is, that the more highly developed and specialized a species or an individual happens to be, the smaller will be the number of its offspring. He notices the explains reversion to type, the tendency of a prominent variation, like genius, to be diluted in mating and lost in successive generations. He makes many zoological observations which, temporarily rejected by later biologists, have been confirmed by modern research of fishes that make nests, for example, and sharks that boast of a placenta. And finally, he established the science of embryology. He who sees things grow from their beginning, he writes, will have the finest view of them. Hippocrates, 460 BC, greatest of Greek physicians, had given a fine example of the experimental method by breaking a hen's eggs at various stages of incubation, and had applied the results of these studies in his treatise on the origin of the child. Aristotle followed this lead and performed experiments that enabled him to give a description of the development of the chick, which even today arouses the admiration of embryologists. He must have performed some noble experiments in genetics for his disproves the theory that the sex of the child depends on what testis supplies the reproductive fluid, by quoting a case where the right testis of the father had been tied and yet the children had been of different sexes. He raises some very modern problems of heredity. A woman of Alice had married a Negro. Her children were all whites, but in the next generation, Negroes reappeared. Where, asks Aristotle, was the blackness hidden in the middle generation? There was but a step from such a vital and intelligent query to the absurd experiments of Gregor Mendel. Prudence. Quaestio Dimidium Science. To know what to ask is already to know half. Surely, despite the errors that mar these biological works, they form the greatest monument ever raised to the science by any one man. When we consider that before Aristotle there had been, so far as we know, no biology beyond scattered observations, we perceive that this achievement alone might have sufficed for one lifetime and would have given immortality, but Aristotle had only begun. The section is over.